All right, so printing is the first topic of the day. We got one more to cover after this, and I will, as a gift from me to you, I promise after this week, I won't torture you for a whole week. Yeah, spring break. So, cups. So this stands for the Common Unix Printing System. This is one thing that we as a Unix-based distribution have to thank Apple for. Cups has been around for a long time. Apple bought it and then put some engineers on it and made it way better than it used to be. So Cups is actually really good now. Supports just about every printer that you could imagine, mostly out there. Through this idea called PPDs. So PPDs, if you've ever installed a printer at home, right? You plugged it into your Windows machine, and especially the older ones, like maybe 10 years ago, it's shipped with like a CD drive or whatever, and you had to install this stupid INF file to make it all work and everything. That's what a PPD is. It's basically a printer definition file. So if you want to know how a printer works, that PPD file is going to explain how to do that, and Cups can read that, which means that if there's a PPD file for it, Cups can make it work. So, anyhow, Cups is a really, really old idea. And while Cups hasn't changed too terribly much outside of getting better, the underlying protocols have. Now, while you don't have to really remember too terribly much about this stuff, these letters are going to come up every now and then. So you're going to get LPR, the line printer remote. This was one of the first protocols that Unix supported. And all the commands that you have to know now to make printing work come from that acronym. You're going to realize that LP and LPR are, they're ubiquitous. They're going to be everywhere. But as we found a need, there was a need back in the day, but as we had the technology to meet the need of this idea of network printing, LPR started to fade away. Instead, IPP came along. So IPP basically supported everything LPR supported, but over networks. And HTTP. So the Internet Printing Protocol uses the same type of technology that a web server will use to accept requests, right? So we didn't have to write a whole new language to interface with printers. We just had to use what was already there. HTTP. So Cups came along, supported both, but favored IPP. So the first thing that you're going to get if you try to install a network printer through Cups is it's going to ask you what protocol you want to use, and IPP is the default. So IPP is pretty important. Anyway, you won't find Cups in Windows, but you will in Unix, Linux, and Mac OS. And pretty much all of the protocols are dying in favor of this cloud printing idea. So, it'll still be around for Linux and Unix, and Mac will probably drop it for some kind of iCloud printing or something like that. As Microsoft just announced that they're doing the same thing. So they have this new Office print, cloud print thing that they're going for. So protocols like Cups may be on their way out. But either way, we got to know about it. Anyhow, so Cups can deal with both LPR and IPP. Doesn't really matter which. The jobs, however they're sent, either of those, are converted to PostScript, which is the more common protocol here, or raster images. So if you've played with Photoshop or anything like that prior to this, you have this idea in the back of your head that there's a difference between raster images and vector images, right? So raster, you've seen these all over the internet, right? If you zoom in on a page, those images get blurry, right? Vector images do not at all. You can zoom in on them a million times and they'll still be crystal clear. That is the difference. Vector images are mathematically based versus raster images, which are pixel based, right? So all that means is that depending on which type you send to the printer's going to try and size it to the page that it's dealing with. And if the image is smaller than the page, there's a good chance that your image is going to be ugly when it actually prints out. So not all printers support PostScript, which led to the conversion to PCL. So this is the one that you see in Windows pretty much all the time. HP created this one, and this one is the one that deals with raster images. So it converts it basically to a big old picture and tries to fit it on the page as best it can. PostScript, however, tends to deal with more vector-style graphics, which means that it blows it up, but mathematically, which means that you tend to not lose quality on words, things like that. Photos are photos. You know, if you give it a raster photo, it can't vectorize it and make it amazing and make it print as big as you want it to, right? This came with the idea that you only get as good as the source. So if you give it a crappy image, it's going to print a crappy image, right? If you give it a good image, it's going to print a good image depending on how it deals with it. But can't get better than the source. Anyway, one of the cool things, one of the advents of IPP is that you didn't even have to actually print to a printer, which gave rise to this idea that you could print to a PDF, something that I make you guys do all the time, right? So what Google Drive does in the background is actually uses IPP, converts it to a PDF, and allows you to download that. And that's really what we're going to focus on this week anyway. So to install Cups, that's it. Pick your distro. There it is. That's all you got to do. Cups is then administered through a web interface, right? So most of the time, you don't even have to at least configure it with commands. You install it, you get to it through a web interface. Well, on Ubuntu, I have neglected to install a GUI, so I'm not able to use a web interface. Well, I guess I can, sort of, through curl or something like that, but yeah, you don't get the cool, pretty images or anything like that. The text looks all weird. So what we're going to do, if I could spell, install Cups. It's going to install a bunch of junk. What's that? I could have, I don't know. I mentioned before that I'm just kind of paranoid about doing -y. And I don't know why, because most of the time I just blindly hit enter anyway. Yeah, exactly, right? I don't know. Something that was ingrained to me a long time ago that for some reason I cannot shake. But then again, space -y is 3 characters versus enter, which is 1. Maybe that's it. Maybe I'm ultimately just extra lazy.
But think about it. You're going to press Y anyway. We have to wait for the Y to come up.
No, because if whatever's capitalized, if you just hit enter, it'll choose that. The capitalized one is the default one.
Say 2 characters.
Yeah. Yeah. I mean, you guys are getting into the habit of using sudo bang bang. How many characters are you really saving? 1. What's that?
So many, because I mistyped times.
So once this is done, we'll be able to print, actually. One of the cool things about this is that you can actually install everything that you need to through the command line, but I'm not going to force you guys to do that. However, I will force you to print through the command line, because it turns out a lot of times you're going to run into these situations where you have a text file that you want to print from a command line and don't have a GUI, so you can't, poke around on like the Cups web interface or something like that. So you can do that on another machine or whatever and push out your text files to a printer. I don't know anybody that does that anymore, but for PDFs, right? You can do that with PDF and then use the protocol SFTP that we used last week or week before to push files to other machines, right? Or pull them from your laptop. Something like that. So anyhow, so if you look, let me see. I've got it down here somewhere. Yeah, there's a little, well, most of it's images actually. Oh, there, it was right there. I just can't read. Because I didn't bold it for myself. I'm just basically blind at this point. So, I think I have curl. Yeah, so curl, HTTP. Oh, let's see. Let's just see what happens. So, 631. Ah, there it goes. All right, so this is what I meant by you can use curl to look at the page, but all you really get is the raw HTML. That doesn't really mean a whole lot to us, especially since we don't really read HTML, right? But what you can really see, if you spend some seconds eyeballing it, you'll notice on like this line, cups 2.2.7, right? You don't need to be able to read HTML to be able to read headings like that. It's cups. So we know cups is installed. That's really all I need you guys to be able to see off something like that. And if you notice on this line right here, owned by who? Apple. So, thanks Apple guys. I appreciate that. So, when you install cups, by default, it only is available to itself, right? So you, on the same machine you installed cups on, can install printers, right? So if you plugged in a USB printer, you need to upload a PPD file to it or something like that to make it work, and then you can start issuing print jobs to it, right? Same as you would in Windows. Go to the browser, click on print. That printer that you installed through cups is right there. Double click on it, click OK, whatever. It'll print, right? Well, cups is more than that. It's actually a print server, so that maybe you got a Raspberry Pi or something like that that you plugged your printer up to, but you want to make this printer available to everybody in your entire house. You can do that too. And that's really where cups comes in handy, right? Because most people don't print much anymore, but you need it for the off chance or something like that. And as I mentioned before, PDFs. What's that? Well, yeah, seriously, right? So PDFs is really where most of that gets done. And like I said, we're going to focus on that. So anyway, if you want to make this print server available to other people, then you'll need to run the remote admin command here. So sudo cups remote admin, ctl remote-admin. And that basically makes it available to anybody as long as you have the IP address of that machine, right? So you literally will not type X's. Please don't do that. It's an IP address that goes into that box. And in SUSE, well, in any other machine, doesn't have to be SUSE, we should be able to. Notice the word should, because when this inevitably blows up in my face, I can be like, see, well, sometimes. Yeah. Find somebody to blame. It's not me. It's the gremlins on the wire. Uh, 10.4, I think it was. 631. Ah, we got something. Because it's HTTPS, you have to have a self-signed certificate, and that is not verified by VeriSign or DigiCert or any of the companies out there that you pay money to do that. So it's going to be like, hey, man, I don't trust this thing. And you're like, it's fine. There you go. So, I'm sorry? Uh-huh. Well, this is basically doing that for you. You're not giving the printer an IP address. You're giving cups, or the machine that's running cups, an IP address. And then whenever you access that IP address, cups makes any printer connected to it available to anybody that is asking. So in a roundabout way, yes, you are giving a printer an IP address, but you can't really refer to it that way because the printer doesn't have an IP. The print server does.
In your LAN, you can enable a cups server.
Yes, you can enable a cup server on your LAN.
To that cup server.
Mm-hmm. Right. I mean, just like SSH, right? I mean, you're not giving the files an IP address. The server has the IP address, and then you can get at the files. Same with the printer. Assume the printer is a file or another device, right? The hard drive doesn't get an IP, the server does. The printer doesn't get an IP, the server does. So the server makes available all those resources to you once you connect up to it. Now to print, on the local machine, you'll need to add anybody to the LP admin group. And this is a command that we used prior, right? That should be familiar. The group is new. So if we do group, notice LP admin number 116 is now available, as well as scanner, SaneD, and ColorD. So LP admin is really the only one that we need to know about. So the CUPS PDF package is important to have. Without it, you won't be able to print a PDF, so you'll need to go and install that as well. And in CentOS, assuming you're doing that there, you have to have EPEL enabled. If you don't, oh shoot, what was it? EPEL something. I cannot for the life of me remember. I did it a couple times in the previous videos. I can't remember what it is right now. It's right on the next line. Yeah. So yeah, if you do that, see what happens when I don't bold it for myself. I totally miss it. So sudo yum install EPEL release in CentOS. That'll enable CUPS PDF, and then you can go in and yum install CUPS PDF if you want. In Ubuntu, it's just part of the universe repository, which is enabled by default, which really just means you can do that without any extra steps.
I do not like CentOS.
Why?
I'm thinking maybe it's because you grab the mouse.
Oh yeah, that bothers me.
It just feels archaic.
It does. Yeah.
It feels like something you found like mass into the bureaucracy.
Yeah, no, it really is. And the real reason for that, why CentOS captures your mouse, is because they don't allow proprietary drivers on install. So Ubuntu and OpenSUSE, they don't care. They do not care. They will bundle it and make things easy on you. But CentOS is more of a, if you want it, you say you want it, and then I'll add it, and then we'll be cool. But otherwise, we're not adding it, so you're just going to have to hobble along until you decide you want to add it. That's the deal.
CentOS, where you say, I guess they're like secure testing.
That's one of the big reasons why, yeah. CentOS tends to try and be more secure, and to do that, they do this whole, if you don't need it, we're not going to add it. Just tell me you want it, and then we'll add it. Yeah, not really more than anybody else. What's that? Ubuntu is the same way in terms of cadence, right? They have a long-term support release which lasts for 5 years. CentOS tends to do 8, though. So if you're keeping up with the CentOS versions, like if you're going from 7 to 8, when 9 comes out in a few years, you go to 9 or whatever, you won't be too terribly behind the curve, but you are set in stone. When you choose CentOS 7, you keep the same kernel the whole time. Like, you will never upgrade. So if you get new hardware for your servers or something like that, CentOS won't support it unless you go and grab what are called backports so that you can enable that kind of functionality or whatever. But to avoid getting too far off the beaten path, the deal with all of this is you'll need to install CUPS PDF to enable the ability to install a PDF printer. However, you don't get away with just doing that. You need the PPD file as well. So in the lab, you got to go download this guy. So y'all have a GUI on Ubuntu, so you can go do this. I can't. Well, I guess I can.
Could you show me how to do that? Because I'm kind of interested.
You go to this webpage and you click on that link and it downloads. To wget it? You can do that. I don't think you can do it with Google Drive, though. So
That's kind of what I was wondering when you first started go to this site and download it without going to the site.
I always provide you guys with URLs, so you can literally just type in the URL after this. wget, whatever, web/file.zip, and that will download it. It will put it right where you are. So that will totally work. But I try not to put you guys in situations that are impossible. So I don't think you can wget from Google Drive. So that is something that you won't be able to do. You'll have to do it through the GUI. But again, you guys should be on Ubuntu. You guys should have a GUI to do this with. So pop open Firefox, log into Moodle, download the PPD. Or if you're clever enough, you can copy the link address and use that. But Google Drive link addresses are stupid. Look at that. So yeah, I don't expect you guys to type that in. So just open the webpage, download the file. because that will be essentially your printer driver. So to add a printer, I mean, you just quite literally come in and you click add a printer, and then if there's a printer connected up to it, let me see. This one should be. Aw, yeah, it's because I'm doing it remotely. You guys will be doing it locally, so you should have printing. Let me see. Oh, and it's not gonna let me. No, actually, when you go through the add printer, it's gonna take you here, and you'll give it a name, you'll give it a description, locate. You know, you can fill this out. It doesn't actually really matter too terribly much what you're actually putting in right here. And then when you go to add printer, you'll come down and there'll be PDF as an option. PDF will be there. I don't remember if it's cups PDF or it's just PDF, but it'll be in that option there. And then you will provide a PPD file, right? The one that you downloaded from right here. So download that on the Ubuntu server. Go through this process on the Ubuntu server. When you add a printer, then you will, oh, I know why that didn't work, by the way. When you click add printer, or I'm sorry, choose file, you'll provide that PPD file, right? Just go into your downloads or your home folder, find that PPD file, double click on it. It'll say cups PDF, where it says no file chosen. It'll say like cups.pdf.ppd or something like that. And then you just click next. That's all you got to do. But if you skipped any of those steps coming up to it, right? You didn't install cups PDF or you didn't install cups or whatever, you're going to have issues. So make sure you install at least cups and cups PDF. You can do that in one go if you want. Provide the PPD file here. If you don't provide the PPD file, that will also break you. So make sure that you're doing all three of those things. Cups PDF, and adding the PPD file during this process. And by the way, the reason that didn't work is because I am in LP admin. Oh, actually, I'm not. I never added myself to LP admin. That's why. That's why it gave me the forbidden back here, because I was logging in as Leo. You need to be logging into someone that has LP admin. So user mod AG LP admin. Yeah, you can get away with that. You can. Yeah, you don't have to do -A space -G. You can chunk them all together. Correct. Yeah. A is append and G is group. Yeah. So add to group essentially. And then if I do ID again, no, might be because I'm not logged. I need to log out and log back in. There it is. I'm in LP admin now. So I should, maybe. Yay! Cool. So cups PDF. This is what I was talking about. It's going to be an option for you. And then the rest of everything looks that way. You just provide the PPD file. Okay. So here's the cool thing. You can now print stuff through the command line. And this is how you do it. Yeah. So the LP command, remember I was telling you back up here, we were talking about line printer remote? Yeah, LP is still the command you use to actually tell it to print stuff, even though you're not using LPR, you're using IPP or something, right? Doesn't matter. LP was created back in the 80s, and we just never changed the name of it, right? Because in the 90s, y'all would be sitting here being like, well, why can't we just still call it LP? It was so easy. I knew about it, LP. Yeah. Anyway, so this is how you'll do it. So we can come in here. How about... Maybe? All right, well, man, LP. Most everything has -help, but not LP for some reason. Really, there is no help. Hold. Oh, yeah, because H's are already taken. Wow. That's a lot. Anyway, yeah, so look at what -D stands for. Prints files to the named printer. So it's really important that you get the name right, right? Make it super simple, by the way. name it something like cups PDF. No spaces, no dashes, no underscores, no nothing. Just cups PDF. Super duper simple. So that when you come down here and you type in LP-D, you can just type in cups PDF right there. Or whatever. You can name it Billy. I don't care. Does not matter. Name your printer. Make it easy. Whatever that is. And then info would be a file named info that exists right here. Right? So you could also do something like tmp.info.text. Right? That doesn't matter. Whatever that, I'll leave that there to make that a little more explicit. So LPR is another older command, and you can use it the same way as LP. But doesn't exist on my system. Yay! So it's just the older way to do it. So it doesn't get installed. But if you are going to use LPR, you have to use the -P for printer instead of D for destination. So just know, either of those can come up on your test anyway. They'll ask about both. Nope, I can still get. So if there were a printer installed, oh yeah, cool, it looks like the PDF, there's already a PDF printer there. But it's a dummy printer, so it's not gonna do much for you. But it tells you PDF. There's a printer named PDF, and it's accepting requests since 11:38:44 at 44 seconds today, right? And any printer you have on the entire system, it'll just give you a whole list. If you've got 100 printers on this computer, it'll give you a list of 100 printers. It'll tell you when they started listening for that kind of thing. So say you got 100 different people printing 100 different things to one different printer. You can do LPQ, and it'll show you every single job in order. The line printer Q, as in Queue, like the line of things. If you need, and it'll number it too, by the way, if you need to remove one of those things, right? The job stopped, you ran out of printer, and now the job's not resuming after you put printer paper into the printer or something like that, you can remove that job and just call the guy back and be like, all right, submit your job again. There are ways to change the priority, right? Like, so if someone's at the back of the line, 100 pages back, but you want them to print next, there are commands to do that kind of thing. So, I mean, it's not that it just doesn't exist, just that we don't need to cover it. So, I'm not trying to hurt you. I'm just trying to cover the things that show up on the test. Backtick. Hey, backtick will actually show up. There's another way to do that, but I didn't show you that because I'm not trying to hurt you. I really promise you, not trying to hurt you. So, cups reject. So if you are running into a situation where the printer is out of paper and you just have not gone to Walmart to pick up, 5 new reams of paper, and that printer is just going to be screaming at everybody for like the rest of the day because you won't be able to go to Walmart till tomorrow, right? You can run cups reject, and in our case, cups PDF or whatever you named that printer, Billy. Cups reject Billy, and Billy will now stop accepting print jobs altogether. It'll say printer is offline. Nope, Billy is not accepting print jobs at the moment. Billy is offline. That's what it will tell you. When you get that printer filled back up with paper, you just do the opposite of that command, which is cups accept Billy, and then Billy will start accepting jobs again. Right? So turn it off temporarily, turn it on. Now, you can do some of this stuff manually. So you can go in to the Etsy cups, and there's a file for every single printer that you have. Oops, not cat. CD. Cups. Let me see. Printers.conf. Yeah. So let's. Cool. So you see, I only have one printer. Default printer is PDF. The info about it is PDF. You can find the name in there somewhere. Nope, it just is info, PDF. So anyhow, accepting, yes. So it's accepting jobs. That is actually what really changes when you do cups reject, cups accept. That accepting line right here. That's the one goes from yes to no. That way, the printer's actually not accepting stuff. So anyway, that's the basics, right? Installing a printer, easily doable through the web interface, remotely, so long as you add that command to the machine. Remember 631. That is the port that CUPS listens on. The web interface for CUPS listens on 631. If you're not giving it 631 when you try to go to that web page, it's going to be like, nah. That's it. It will really just say nah. Adding a printer, fairly simple. And here are the commands that you're going to need for the lab. You'll want this one. That's how you're going to print to that particular printer. And when you print to a PDF printer, it just creates PDFs in your home directory. So instead of like printing a page and spitting it out of a printer, it actually prints a PDF and sticks it in your home folder. So that's where you'll go. When you print stuff, that's where you'll go to find the copy of the thing that you printed. All right. So other hardware. So this is a hardware chapter, so we can talk a little bit more about hardware. And we're really just looking at the different kind of hardware. We talked about modules, at least kind of buzzed by modules, which is this idea that you can add more hardware to your system if you want. And if the kernel doesn't support it by default, you can use modules to add functionality to it. ZFS is like this. ZFS is a file system that is extremely resilient. It is pretty much, it's RAID, but on steroids, right? Y'all, you know the RAID 0, RAID 1, RAID 5, RAID 6, RAID 10, RAID whatever, right? That idea has been taken further and expanded upon with ZFS. But ZFS is not supported because it deals with disks. It has to have a module. But that module has not been added to the kernel itself. So if you want to use ZFS in Ubuntu, you have to add that module. Luckily for you, you can just do, I think it's just ZFS, but let's see. ZFS Fuse. So if you install ZFS Fuse, it'll pull in a bunch of other stuff, ZFS DKMS, a bunch of other things. That'll let you support ZFS. But it imports those kernel modules, so it'll install ZFS DKMS so that you can build the modules so you can run it, right? That's the idea of this whole thing. And so to check on any modules that you have installed, lsmod. If it's got a 0 by it, it's not on. But if it's in this list, it is available to you. And on the right-hand side, so notice like async memcpy, you'll see the size of the module, which is about 16 kilobytes. How many times the module is requested? 2. And then by who? RAID 456 and async RAID 6 recov. Right? All that is it's telling you the module on the left-hand side, the things that are requesting it on the right-hand side, size of the module, and how many times it's being asked for. That's really what all of this stuff means. Then LSCPU. Information about your CPU. Yeah, it is. It is. It totally is. That's why LSHW is a lot better because you can do things like that, right? It tells you just the basics, just the overview of what's going on. So notice it says processor there, Intel Core i5-4590, CPU 3.30 gigahertz or whatever. LSHW really just pulls from this anyway, right? Notice model name. It's exactly what LSHW shows you. But LSHW is not available on pretty much every system, so you got to know the basics. These are the basics. LSMod, LSCPU. So LSCPU will show you everything you want to know about your CPU. LSPCI will show you everything you want to know about what? Anything that's connected over the PCI bus, right? That's your SATA controller, all of your hard disks. That's anything that's coming off of the North Bridge. So your faster things, the faster stuff is going to be on LSPCI. So yeah, your network controller, things like that. LSSCSI. Oh, not in there. Only shows up whenever you actually have a SCSI bus on your machine. SCSI is a really old way of dealing with hard disks. So you probably won't ever see it in your life. But you will see SAS, which is SCSI on steroids, right? Serial attached SCSI. So it's using a SATA interface, but SCSI technology. That you will see. But to you, that won't look any different than a SATA drive. The interface that you plug into is slightly different. There's more plastic, but it's the same interface. So it's like backwards compatible. You can use SATA disks with a SAS controller, but you can't use SAS disks with a SATA controller, right? So you can only go faster. You can only use the better bus. You can't go backwards. SAS is the better bus. So anyway, that's kind of tangent, but LSDev, yeah, and it told me to do that, so I'm not doing anything that, like, just from memory or anything like that. I typed in LSDev and it said it wasn't found, but you can install it with proc info. So I just followed what it told me to do. And so these are devices, right? Every single device that shows up on your entire machine, USB, PCI, anything shows up under LSDev, right? So you can see keyboard, PCI bus, the sound card in there, ACPI modules for the BIOS, all kinds of cool stuff, right? VGA, all kinds of things. So that's pretty much every loaded device. If it is loaded, it shows up in this list. LSRAID, if we had MDATM, doesn't show up. If we had MDATM installed, LSRAID would show us any kind of RAID arrays. LSUSB, you guys can guess what that one is, hopefully. Maybe? What does it show me? Yeah, anything on the USB. Well, the B in bus stands for bus, so Universal Serial Bus, USB bus. So it'll show you everything. Every USB device that you connected, it will show you listed here. So if you plug in a device and you're like, I don't see it, and you do LSUSB and it doesn't show up in the list, yeah, Linux doesn't either. So it may be a problem with the hardware, it may be a problem with the plug that you're plugging into, stuff like that, right? LSBLK, this one is the one I use the most. List block devices. So anything that stores data, LSBLK will show you. So UDEV, if it shows up in any of these, minus dev, so LSCPU, LSPCI, LSSCSI, LSRAID, LSUSB, LSBlock, has to go through UDEV. So UDEV is basically the little demon that runs in the background that listens for new hardware. You plug it in, UDEV is like, hey, there's new hardware. And UDEV is the middle guy that says, hey, kernel, there's new hardware coming on. Here's the module for it, be ready. And the kernel's like, all right, cool. And at that point, you're able to use that hardware. UDEV facilitates that whole song and dance. If you want UDEV to behave differently than the way, no, you don't. You just need to know that this file exists. Seriously, that's it. If you want UDEV to behave differently, then you can go configure that in this file. Rules.d10. Oh, it's under snap. It's under something different. Snap core rules. And then you can find underneath here. Right. You typically don't. You typically do not. But you got to remember that everything on Linux is a file. Everything. And, you know, in Windows, it's a registry. The registry in Windows looks this bad. It really does. But because everything in Linux is a file, you don't have this idea of a hive that contains all these keys that have all these attributes inside of it. You just have a file that defines the same exact stuff. So just know that it exists. And know that if you wanted to change it, you would go to this directory. And in that directory will be a file, typically 10-local, but at least in the most modern versions of Ubuntu, it's 70-snapcore or snapdev or whatever it was. Yeah. .rules that will configure all of that. Right? And that's the only file that's in there. So that's where all those rules are. I would imagine in CentOS it's probably the right one. 10 local, whatever. Let's look in open SUSE because that's what I got open. Any day now. There it is. Less Etsy udev rules D. No, they're the same way. So they've got separate rules files inside of there that deal with it. So anyway, just know Etsy udev rules.d. That's what you got to know. That's the directory that all the rules exist in. All right. So now we get into troubleshooting. We get into this idea, and this is not the only troubleshooting that we're going to get. We're gonna hit some other commands. You guys have already seen top from last semester. I don't think we've covered it yet in this semester. The top command, we've already hit it in this semester. Okay, all right, yeah. So we'll hit it again. We're just not going to hit it yet. So these are going to be all the troubleshooting techniques that we will not hit anywhere else. So that way we kind of block it out a little bit. Yeah, that's exactly what it does. Yep. Top shows current process. Oh yeah, because we use PSAUX, or PS is what we used a few weeks ago to, yeah, remember, because y'all were using screen to go back and forth and run some commands, and then you had to go find them in PS, and then you had to kill it, and yeah, that whole song and dance. That's what it was before with PS. Now, anyway, so in every Linux system, you have this idea of a disk scheduler. So a scheduler is a way, or the instructions on how a disk handles multiple requests, right? Because, see, computers do hundreds of things at a time, especially if you're a server of some kind. Imagine you're a NAS and you have 1,000 customers and you got 50 people hitting that NAS all day, every day. How does the disk know who to service first, right? How does this figure that out? So you have schedulers. You have, and these right here, these three are the ones that you need to know for the test. You have Noop, which is basically first come, first serve. If you ask me first, I'm going to complete yours first, and then you're going to be the first one out, and then I'm going to go to the next one, and then we're going to complete that, right? But if you have 100 different people requesting 100 different things, the first guy that wants to move over 115 gigabytes of stuff is going to hold up everybody else in line, even though Betty wants to move a 1 kilobyte file. She changed 4 words in that Word doc and wants to just re-upload that, right? Betty's going to have to wait until that 115 gigs is done copying before her thing is done. And God forbid her computer shuts down in that time, or she reboots, or she does anything, right? So Noop is great if you have a linear, one request at a time style disk request, right? So if you got one database and that database is the only thing running on that disk, then all right, Noop is going to be great for you. But otherwise, it's probably not going to be so good. CFQ, completely fair queuing. Basically, just goes in order. Says, all right, I'm going to write 5 blocks for you, then 5 blocks for you, and then 5. So you have 100 different people wanting to write 100 separate files. Some of those files are 10 gigs. Some of those files are 5 gigs. Some of those files are 5 bytes, right? So huge different amount of file sizes. And CFQ is basically just going to go down the order. Give everybody a little bit of time. Yes. Everything that happens here has a process running in PS or something like that, or in the system that is handling all of this. But this is the rule set that they go by. So, I touched that 10 gig file a little bit, touched that 5 gig file a little bit, touched that 5 byte file a little bit. Well, it turns out I only needed to touch that 5 byte file once. So now it's out of the queue. I'm done with it. I've already written what I need to write onto the disk. So now I'm just cycling between that 10 gig file and that 5 gig file back and forth and back and forth and back and forth until that 5 gig file is done, right? And then I got about 5 gigs to go on that 10 gig file. And then I'll just focus on it. Unless you've got more requests, right? Betty comes in. She wants to upload another file. And then I'm done with the blocks for a little bit on that 10 gig file. I come touch Betty a little bit, get her file in there, and then move back to my 10 gig file. So CFQ tends to be the most popular of the 3 basic disk schedulers. So you'll find that most systems use CFQ. Then there is Deadline. So Deadline has 2 separate queues, a read queue and a write queue. And read queues have higher priority. Because don't forget, we don't just use disks to write to, we read from them, right? And so, let's say you've got 4 different people running on the same system or something like that, and you want to run SSH. But SSH hasn't been used yet, so it's not in RAM. So it's got to pull from the disk, right? What if someone is running a 10 gig file transfer and there's no difference to the scheduler between read and write? Well, SSH is not going to get read off that disk until your 10 gig file is done transferring. So you're going to have to wait to SSH for like ever, depending on the speed of your disk, right? Well, not necessarily, but there is less latency involved, right? Because there's no ARM having to move back and forth to, well, no, I take that back. No, the latency will probably be pretty similar in both, but it doesn't necessarily take more time to do either or. But reads have more priority because in this scheduler, because they assume that reading is more important. Right? Reading will give you the semblance of a slow computer more than write will. You know? Like if you're copying a file over to the flash drive and it's like it's scooting along, you don't really think too terribly much of it if it stops for a second and then continues on its way, right? So in Deadline, it'll basically stop that transfer for a second so it can go read SSH off the disk and then put that into RAM so that you can get on with your day. And then that file transfer will continue on. So that's really kind of the idea with Deadline. And all of these are just different ways to do the same exact thing. And most of the time, you don't touch it, ever. But in very specific scenarios, like all I do with this disk is run a scheduler, or is run a database. So I want the Noop scheduler, right? You'll go in and configure that, because you'll get more performance out of Noop than you will with CFQ in a situation where you're running a database. So, when you are as big as Google and you have the title of engineer, you get to make that decision. But, as a tier 1 tech, you're probably not messing with disk schedulers. So, just understand what a disk scheduler is and those top 3. Noop, CFQ, and Deadline. That'll change in a couple of years because we'll have better schedulers, and it's already happening. You've got MQ Deadline, Kyber, and BFQ as well. Do not commit those to memory. They are not important for this test, but they exist. Because if you follow what I'm doing here, and you do it on a random machine, there's a good chance you might do it on a CentOS machine, and there's a good chance that you'll not see any of these 3. And you'll be like, well, Leo said that those are the 3 important ones. Why does that? Yeah, I'm writing them down so that you know that they exist. But on Ubuntu, if you go do this, how do you figure out which scheduler you're using, right? You go cat this file. SDA, Q, scheduler. Now look at those, Noop, Deadline, CFQ. One of these things is not like the other. That's how you know which one you use. Which one you are using right now. Completely fair queuing. If Noop had the brackets, it would be Noop. If Deadline had the brackets, it would be Deadline. Right? And the way to change it, again, don't do this unless you have a good reason to, but you get to use a little bit of command, or you get to use, command redirection. So you'll echo Noop into that same file, sys block sda q scheduler. right? And you would need a sudo to do this. That basically echoes the word noop into that file. So that basically writes the word noop into that file. But the way that that file works is it's special. And that means that if you tell the file noop, it will change the scheduler to noop. It won't actually write that into the file. It'll just take that as input and replace your current schedule with the scheduler you said.
Why didn't you use the backtick if you're going to do redirection?
So that was output redirection. I think I said command redirection earlier. So that's output redirection. So you take echo and you do noop. What you get is that, right? You get the command line to say the word noop. And then you go in and say, don't put it out on the command line, put it over here. And then you specify that file. So that's what's happening there. Anyway, so these are your other schedulers. Just know that other schedulers exist. And if you want to, if you have that burning question inside of you, well, how do I know which one I want to use? There are websites dedicated to pitting these things together and showing you in the different scenarios on an SSD, on a hard drive, on a this, on a that, whatever, which one comes out on top in specific scenarios, right? So if you want to see, I think they have a database one in here. Maybe not. No. Oh, SQLite. Yeah. So CFQ and Noop, then Deadline, in that order, are faster when you're dealing with databases. Then MQ Deadline, then Kyber, then BFQ, and then not using a scheduler at all. So anyway, that's totally a thing. So engineers don't just know for no reason, right? They go out to websites like that, or they run the tests themselves to figure out, all right, well, it looks like we're going with CFQ because CFQ beats the other one out by at least 50 megabytes per second. So therefore, we're saving time by going with that. Here's a more modern one. And they have pretty graphs and stuff, right? But, right, SQLite. So MQ Deadline got some updates in going from kernel 4.12 to 4.19 and is now king of the heap when it comes to SQLite, so dealing with database. So you got a real question. Do you go with the tried and true Noop? That is obviously good with databases and has been for some time. Or new guy on the block, MQ Deadline. That is seemingly, oh, actually, no, I take that back. I'm reading that wrong. Yeah, fewer is better. So actually, MQ Deadline's worse. Noop is Noop is bad as well. CFQ seems to win in that one. So adding things to the database. Yeah, I know, right? You gotta actually read the graph to know what you're looking at. Yeah. So basically, read before you interpret those things. That's what I get for not reading. Anyway, that's the idea, right? So, yeah, seriously, I confused myself. So anyway, be aware that there are benchmarks out there that will tell you which one to choose in your particular situation. If you don't want to think about it too terribly hard, right? Let someone else do the thinking for you. They've already done it, most likely. All right. So, there's a tool for everything. Absolutely everything. You want to know how fast it'll be to do a round trip network hop from this place to that place. If you want to see how long it takes to write 4 kilobytes of data to a disk, if you want to see what kind of information or how much information is being written to the disk at this current moment, like everything, there's a way to see it. The hard part in Linux is knowing what to say and when, right? If you want to see that 4 kilobyte test, well, you'll use IO ping. So IO ping is not installed by default. So you got to install it. But after you do that, you're able to, I think it's going to yell at me if I don't specify. Yeah, I won't tell you. So you do sudo IO ping and then tell it a partition. Right? SDA 1 or SDA 2. I think 1 is where all my stuff is. So if I do sudo IO ping here, It's giving you some basics on this disk. Now, if you ran this on an actual machine without being in a VM, it'd be quite a bit faster. And the funny thing about that is that it'll only be like an extra millisecond faster or so, maybe 1 to 2 milliseconds, right? Most fast tests on fast machines happen in microseconds, not milliseconds. So that little U, that little micro mu symbol, whatever, is what it would be measuring it in, as opposed to milliseconds, right? But that's the idea, right? You're looking at IO ping. IO ping is basically telling you how long it takes to get the hard disk to respond whenever you tell it to do something. In this case, it's taken 2.8 milliseconds, 2.5, 2.4, 2.6, right? Notice, 2.76 milliseconds is what? Slow. If your disk is taking 2.76 milliseconds to respond back to you when you tell it to do something, it is slow. How fast is 2.7 milliseconds? Faster than that. But yes, you got the right idea, right? If it doesn't happen in an instant, it's too slow. It is too slow. So that gives you an idea of how fast computers can actually be. So anyway, you can do IO ping to give you an idea of how to do things. How fast do you want it to happen? How many times do you want it to happen? Right? That's the idea with this. So use IO ping help in your lab to help figure out how to use IO ping. Because I'm telling you to use IO ping, but I tell you to use it in a very specific way. So you'll do IO ping help to figure out how to do 50 of what I'm asking you to do, right? So that will help. IO top is another command you got to go install. I don't think I actually have you do this in lab though. But this is a really good command to run on a file server. You're going to see just how fast the disk is being used at any given time. Look at the very top of that. You see total disk write and total disk read. And it ain't doing nothing right now, right? And that's what, right? I mean, nothing would be happening. I'm not doing anything with it. But as you start pulling files over to the, say you've done a share file thing or something like that, or SSH or whatever, you'll see that number start to, there it goes. It does stuff every now and then. But you'll start to see things happen in the background. See if I can get it to do a little bit of something. Maybe. Did it move a little bit? Just a little bit? Yeah. Oh, here we go. See if I can get it. There it goes. So now that I'm doing stuff on that server, over SSH in this case, but it doesn't matter, right? And then you do, this is where you'll really start to see some busyness. Once it's done downloading stuff, you'll really start to see it kick up, right? Once it starts adding things to the hard drive more than just downloading a file slowly, right? If you notice, look, 988 kilobytes per second. Notice total disk write is about 988, 1028, right? The disk is only moving as fast as I'm downloading these files. But I won't make you guys wait a minute and a half. But that's the idea, right? Once it starts processing, you'll start to see a whole lot more disk activity than that. But it's just a good way, and Q to get out of that, by the way. That's just a good way to keep an eye on disk activity. If you're curious if you're using disk, this is a good way to look at it, right? If you think your disk is being slow, you can use IO top to start probing your disk, like, hey. And if your disk is real slow to respond, like more than a millisecond or so, then yeah, you're starting to see some real IO slowdown, so input-output, right? It's slow to respond, and if that's the case, well, you need to figure something out. All right, so just a couple more to go. Uptime. is a command that will show you the current time, how long the system has been up, and in this case 1 hour 8 minutes, how many users are logged in to users, and your load average. Load average is one of the hardest concepts to get people to understand because it's totally different on different systems. And not just the number. We're talking if you've got a dual core system and a quad core system, that load average, that 0.35 load average means two totally separate things. So, load average. This is the idea. So, right here, you got 1 minute, 5 minute, and 10 minute, or 15 minutes, load average. What that means is how much in the past minute your CPU has been used. So this is not an instant, like a little wire graph like you get in Task Manager. See this? That is not load average. That is current load. That is not what uptime is trying to tell you. Uptime is trying to tell, so like if we follow this along, right? Notice that, hey, let me just do it like this, right? So if Linux were giving me a load average here, so let's say I had one CPU. It's just a way to visualize it, right? That load average would be 0.5. If you look at this, and I'm generalizing, this is more like 40% or something like that. But 0.5 would be my load average here because this line is hovering at about 0.5. 0.5 of one core. I'm using half, right? So using all of one core would be 1 over 1 minute. If you see that in the 5 minute column, then it's been pegged out for a whole 5 minutes if it's at 1. If you see that in the 15 minute column, it's been pegged out for 15 minutes. That starts to get a little troubling. If you have a reason for it to be pegged out for a whole 15 minutes, then okay, cool, leave it alone, don't touch it. But if your system is pegged out for 15 minutes and you don't know why, well, it's time to go investigate. It's time to go figure out why it's acting this way or why it's being used so much. But yeah, this is like 1 minute load average. You would see 0.5 in this column in uptime. The longer that runs like that, that will start to tick up to 0.5 and that will start to tick up to 0.5. Yeah, maybe so. Maybe so. So, yeah. All right. Well, here's the thing. Load average is just that, an average of the cores being utilized on your system. So if you had a dual core system, then that means to have a fully pegged out CPU for a whole minute, the number would be 2. 1 for fully used up one core, 2 for fully used up both cores. Which means that 0.5 on a dual core system and 0.5 on a single core system mean two totally separate things, right? 0.5 on that dual core mean that you're only using a quarter of your full potential. But 0.5 on a single core system means that you're using half, right? So on a quad core system, what does 0.5 mean? An eighth, yeah. An eighth of your system. So it's something like, what? 12%? Something like that? Of your total muscle, right? And then for an 8 core, it would be half of that. So the numbers totally depend on how many cores you have on your system. So be aware. That's what uptime means. Now, here's the thing. On a single core system, you can have a number bigger than 1. It doesn't seem intuitive, but it is. What it means is you are using more than your one core can handle. So if you see a number bigger than the number of cores you have on your system, that means your CPU cannot keep up with the current load. So if you've got a dual core system and your load average is 2.5, you need an entire half additional core to be able to keep up with the current load. So They don't really make 3-core CPUs anymore, so you just go buy a quad-core and you'll be all right in that situation. That's what that load average is trying to tell you. That's why load average gives you different information than what you're looking at right here. This graph can't go past 100%. So it can't tell you how much more it might need. But load average does. And so it can give you that insight into, all right, I know we're fully used up, but how much more muscle would I actually need to be able to handle this current load? That's what load average is trying to tell you. So we spend a lot of time on that, but it's really, really important because every single thing that you do in Linux as far as CPU goes, there will always be a load average. You will always get that value. You may or may not get a 50% used, CPU percent used or whatever. You may not get that value, but you will always get load average. So understanding what load average is better than understanding, right? Look at that CPU. It's sitting at 0.7. Great. What does that mean 5 minutes ago? Nothing. But look on the right-hand side, you see load average. So the graph on the left shows you right now, load average shows you 1 minute ago, 5 minutes ago, 15 minutes ago. Gives you good ideas. Now, HTOP will never be on the test, but it is pretty colors, and I like pretty colors. So, yeah. And it has all those things that I was talking about.
So if I came up with a cloud-based virtual pool, I'll probably be rich.
What do you mean?
A cloud-based virtual where you can add cores to your computer through my cloud.
Oh, they've already done it. They got you on that one already. Totally have already figured it out to add CPU cores to a VM that's still running. Yeah, totally have. And I mean, you can thank AWS for that. You paid lots of money for that, but yeah. Look up the word scaling. That's the idea. So you've stumbled upon the idea of scaling, and AWS does that. They were the first to market that I know of to be able to do that. Yeah. So anyhow, IOStat. Same basic, sudo apt install sysstat. I think I even tell you to do that in the lab. Boo. So IOStat will show you both CPU and memory information. Or disk information. So this is kind of like IOTop, where it will give you the current read of a disk or something like that, but it doesn't give it to you like over and over and over and over again. You can get it to, but -C will isolate just the CPU stuff. Oh yeah, here I've got the example of it. So if you want IOStat to run, let's see, C510. Wait for it. Yeah. So IOStat's running every 5 seconds, and it'll do that 10 times. That's what that means. Oh. But that is just CPU, so if we do it without, you'll get disk stats as well. Right? So -C will isolate the CPU, and I think it was -M. Ugh. Oh, no. Oh, D. Okay, so it'd be D for disks. All right. Anyway, all the CPU information, actually all those commands, all those everything that we've been running so far actually pulls its information from proc CPU info. LSCPU also pulls from that file. So this is really where all the information is stored. All these other programs are just taking bits of that information that live in that file and presenting it to you in a way to read a little easier. And so same with mem, proc mem info. So free, this is the last topic, I promise. So free and VM stat are the last things we'll talk about. W's a little better. So look at that bottom one. So under memory, you got total which should be apparent, right? Let me add H to it. That way that make them a little more human. H for human, readable. W for wide. It breaks out buffers and cache into their own categories. So total, 1.9 gigs. That should be obvious. It's a 2 gig system. Used, 130 megs. Free, 1.1 gigs. Shared, 1 meg. Buffered, 60 meg. Cache, 660 meg. And available, 1.7 meg. All right, so total used and free should kind of be obvious. Shared memory is memory that's used up by libraries. So we talked about .so files back in the day, or back like a few weeks ago. Any library that's loaded up in the system is going to be put into shared memory. That's how it breaks it out. Buffers. Information about information. That gets a little recursive, but it's about metadata. So if you are going to write a file or something like that, that goes into buffers first. So your memory is going to remember where to put that file, and then it will start to act on it. So buffers has about 60 megs of information about stuff, right? It's metadata, data about the data, right? So if buffers gets cleared, you're probably not going to lose a whole lot of information. You might just have to re-queue up that copy command or something like that, right? That's the worst that would happen. Cache is memory used by files that are currently open. That doc file that you just double-clicked on, that gets put into cache and then read from cache whenever you edit it. When you save it, it gets removed from cache and written to disk. That's what cache is about. And then available is memory available for new processes, right? Free is really the value that is free, like as in not being used for any purpose whatsoever. Available is the memory. We can lose 0.6 gigs of data without harming any currently running process. So it's available to the system. We would just have to blank it first. 0.6 gigs would have to be blanked first, right? As opposed to the 1.1 gig free over there. Free is what is really literally not being used. Available is what is available to the system. Some of that memory might need to be zeroed out first. But free and available are really talking about the same idea. So, yep, this is the command I used. Wide to break out buffers and cache so you can get the individual values instead of, if you look, well, here, let me just do it without. Buffers and cache are slapped together. So if you want the individual values, you got to do W to break them out. VMstat, same basic stuff, right? And if you're curious, what is SISO, BIBO, INCS, US, SY, ID, WA, ST? Yeah, all those. What? Oh, got to be able to type. Come down and it will explain to you. SI, swap in, swap out, blocks in, blocks out, interrupts in, context switches, right? All of these things. And there's an explanation for every single one of those values. So if you're using VMstat and you're like, okay, all right, I know under CPU he wanted me to get the SY value. What is the SY value? Time spent running kernel code. System time, right? How many milliseconds we're using at that time to deal with kernel requests, kernel interrupts, things like that, right? ST, time stolen from a virtual machine. You shouldn't see that very often, but you'll only see that on a hypervisor. So if you're running VMstat on a hypervisor and you got like 70 VMs running, there's a good chance you're gonna not have ST being 0. You're probably gonna have ST being something else, something bigger than 0, right? So, and then this is just a reminder that sometimes you got to install these packages to be able to run them. But that's it. I only stole 6 minutes from you. And that's the whole deal. That's the whole shebang. And the lab is using that stuff, right? In Ubuntu, we're installing a printer, doing that printy stuff. In CentOS and OpenSUSE, I had mercy. 2 commands each. That's it. Right? Show me the disk scheduler. Show me IO ping with a count of 50. That's what I was talking about before, right? And then show me the disk scheduler. I want you to do CentOS so you can see the weird ones. And then Current memory used by buffers. Ooh, I was just talking about buffers. So if you want to know about buffers, go to the end of the video. The last 10 minutes of the video and I'll talk about buffers. And that's it. Just extract that information from me. I don't care if you highlight it, circle it, write it underneath the image. I don't care. I just need to know that you know what you're talking about, right? Write the buffer value or circle the buffer value or whatever. And that's it. Absolutely it. Do not forget to download that file and install it into Cups. Otherwise it won't work, right? I feel like I needed the clap emoji every time. All right. Anyway, that's it. That's all I got for you.